This is the 8th video in the gram-mole atom/molecule conversion series. This is the last one. Anything I do beyond this will just be if someone requests some more problems, maybe just want to see a few more worked out, drop it in the comments. I'll definitely get something together if you need to see more. But we've already done gram-mole atom, and we know, we just learned when we went back and forth between mole and molecule, molecule, mole, that really it was the same as mole, atom, atom, mole. So it makes sense that gram, mole, atom and gram, mole, molecule are really the same things. Again, we're just using a different word here because if we're working with a molecule, we need to use the word molecule. And if we're working with an atom, we need to use the word atom. For that reason, I'm only going to do one of each. I'm going to do one going one way and one going the other. And again, if you need more, just let me know. So we're going to start off with a gram to molecule problem. And this says, how many molecules are in a 100 gram sample of N2O? So I look at this problem and I'm saying, okay, they're giving me grams. They want to know how many molecules. I know that's not a straight shot, but I know I can go to moles, and then I can get to molecules. So kind of think about your plan before you start. And you know the first thing we write down is the given. So our given is 100 grams of N2O. And the cool thing about this again is, as beginning chemistry students, you don't even have to know what that is. You just need to recognize it as a molecule, and then you're just following the same procedure over and over. These are just things you have to know so that you can get on to the more complex things. So we've got our given written down. We're going to draw our long line and our short line, and you have grams, and you say, okay, where can I go? You know you're going to have to go from gram to something else because gram has to be on the bottom here. And the only place you can go from gram is to mole. So we've got to write down the mass of N2O. Now, this presents not really a problem, but N2O is not on the periodic table. So if you'll remember from the molar mass lesson, we're actually going to have to figure out the mass of N2O before we can move on. So on a separate sheet of paper, we'll just go ahead and do that in case anyone's unclear on how to do it. So when you have N2O, you have 2 N's and 1 O, 2 nitrogens, 1 oxygen. The mass of nitrogen is 14.01. The mass of oxygen is 16.0. I'm not putting units here because this is just my scratch work. So this is 28.02 and 16.0. And when you add those together, you should get about 44.02. And that's grams per mole. So what I did real quick was I just figured up the mass of this was about 44.02. And again, that is the lesson on molar mass if you need to go back and review that. So I've got 44.02 grams of N2O per mole. I have magically just gotten rid of grams. Now I'm dealing with moles. So you know mole's going to be on the bottom here. And it's so great that mole never has a number with it. So you know, okay, I'm just going to put mole there. Where am I going? I'm going to molecules. Do you know how many molecules are in a mole? Yes, you do. There are 6.02 times 10 to the 23rd molecules of N2O. I never draw that line long enough per mole. Moles cancel, and we are ready to finish the problem just by calculating everything up. So the first thing you're going to do is you're going to multiply 100 by 6.02 times 10 to the 23rd. You're going to hit equals, and then you're going to divide by 44.02, and that is going to give you 1.37. Oops, sorry, no, wrong one. That is going to give, 1.37, my bad, times 10 to the 24th. Like I said, we're not fancy here. Molecules of N2O. And like I tell my students, especially when I'm working off the cuff here, check behind me. Make sure you're getting the same answer. If you find a mistake, let me know. So does that make sense? So let's think about this. This is a really big number. That's actually bigger than a mole because the exponent on a mole is 23. But it makes sense if you've got 100 grams of water, there are going to be a lot of molecules in that. So yeah, that seems like a reasonable number. As opposed to if you got something like 0.82, well, it wouldn't even make sense to have 0.82 of a molecule. Or if you got a number like 6.3, you know there's more than 6.3 molecules in any sample of anything that you could see. And I think I just said water a second ago, I meant to say N2O. So this number makes sense. Anytime you are converting two molecules, you expect you are going to have a lot of molecules. So now let's look at going the other way, and this is the sample with water. What is the mass of 4.5 times 10 to the 23rd molecules of water? So this time, think about, okay, if I had that many little water molecules, the little H2Os, we always draw them like this when we're drawing their pictures in chemistry. If I had this many of those and I lined them all up, what would be the mass of that amount of water molecules? That's what we're figuring out. Just to kind of give you some sort of relationship on the size of that sample. So we're going to write down the given. We have 4.5 times 10 to the 23rd molecules of water. Go ahead and draw that long line and your short line, and you're ready to go. Now, I know molecules are going to have to be on the bottom because they're on the top here. But the question is, where can I go from molecules? Well, anytime you're in molecules, the only place you're going to go is moles. So how many molecules are in a mole? And we know that answer is 6.02 times 10 to the 23rd molecules of H2O per mole. Molecules cancel. Again, moles by itself. And now you say, okay, I'm in moles. I know I'm going to have to go from moles, I'm going to have to go from moles, in this case, to mass. I mean, you don't want to go back to molecules, so really grams is the only place you can go. So you ask yourself, how many grams are in 1 mole of water? Again, I can't just look water up on the periodic table. I'm going to have to figure that up. This is one. Once you do it a couple times, you're never going to forget it because we use water all the time in chemistry. So you have H2O. That is 2 H's and 1 O. 1 oxygen, I should say. The mass of hydrogen is 1.01 grams per mole. The mass of oxygen is 16.0 grams per mole. So that's going to be a 2.02 and a 16.0. You add those together, the mass of water is 18.02 grams per mole. And again, that's one you are probably not going to have to calculate very often. We use it all the time. You're just going to know it. So this is the molar mass of water, and this is what I'm going to have to plug in order to go from mole to gram. So there are 18.02 grams of water per mole. I know I'm done because the problem asked me to solve for mass of water. I have mass of water on top. That's kind of like your little stop sign. Say, hey, stop, it's time to calculate. And you are going to multiply the 4.5 times 10 to the 23rd by 18.02, hit equals, divide by 6.02 times 10 to the 23rd, and your answer is 13.47 grams of water. Just to put that in perspective for you, if you had a 50 milliliter beaker, like about yay tall, most of you have probably seen a 50 milliliter beaker, that's going to be just a little bit of water in the bottom. It's not a gallon of water. It's not a pool full of water. That is just a little bit of water, and that would be about the equivalent of 4.5 times 10 to the 23rd molecules. So that makes sense. And again, it's kind of hard as a beginning chemistry student to have a lot of perspective on this, but most likely you're not expecting some enormous number like, 6,000 or 4.0 times 10 to the 28th. This looks like a reasonable number, and that just comes with practice and experience. So that concludes the gram, mole, atom / molecule conversion lessons. I hope these have been helpful. Again, not fancy. I want you to feel like someone is sitting beside of you and just saying, hey, here's how you do this. So you can let me know if this type of tutorial is working for you. Do you want to see more of it, less of it? And practice some problems. Go back over them, see if you can do them yourself, and let me know if I can help you on any more.